this video, I want to show you how all of these functions are similar, yet different. What you'll notice is the power on all of them is different. All right, you have 1, 2, 3, fractions and negatives. And all of those, if you look at the colors, match these graphs. And you notice how they have certain similar points, but different curvature and different look. For this first function, we have a 1 power, which is a linear function, as you can see, a line. The next function is a quadratic function, and that's when you have a square, and it has this parabola shape. When you come to the cubic function, you put a third power up here, and we call that cubing something. And it has this shape right here. With the square root function, it has a 1/2 power, and a 1/2 power is a square root. It's just this is a more common notation than a 1/2 power. Now, why does it only have a function for a domain greater than 0, greater than or equal to 0? Is because anything less than 0 would give you a negative in a square root, which would be imaginary. So square roots are a little unique. With a cube root function, you have a 1/3 power, and a 1/3 power is also a cube root. They're the same, it's just this notation is more common than this one. And a cube root looks like this. Now a cube root kind of looks like a square root, but it has this side because you are actually allowed to put negatives into a cube root and they don't malfunction. So we get the full function, every full domain of all real numbers. Our last function is the rational function, which is a negative power. Well, a negative power, what you have to realize is a negative power is really a fraction. So really, this is a fractional or ratio function. And there is nothing here at 0 because you cannot divide by 0. So there's something called an asymptote that's drawn right here, creating the I can't draw this spot. Now that we have talked about all of these functions, you can see them all on one graph. Do you see how they all have a spot at 0, 0? Because h is 0 and k is 0. hk on all these functions are 0, and your a value is 1 because from this 0, 0, you go over 1 and up 1. And for many of the equations, you also go over 1 and down 1. The weird thing about a parabola, it goes back up because when you square a -1, it becomes positive, where the rest doesn't have that effect. Or with the square root again, cannot have anything on the left side because you cannot square root a negative. But you can see very shared values, and always hk for every single one. And you can see each equation by its color. So here is what happens when you make your a value -2, your h 1, and your k 2 for each of these functions. So hk is 1, 2, so that would be a -1, 2, because remember, h is always opposite. Is that negative in there? So -1, 2 is the center now of all the functions, and -2 is kind of like a slope. It's like multiplying factor. So what happens is all the graphs, when you go over 1, had a multiply factor of -2. They normally would be up here because when you be a 1, but when you multiply by -2, they flip and stretch vertically 2 times as much. And then you have your opposite got flipped over as well. And that's, you can see the same graphs, everything's the same as before, it's just been stretched and shifted. So for this last function, we have an a of 3 and an hk of -1, -2. So hk of -1, -2 would give you a center value right in the middle of 1, -2, because again, h is always opposite, and a stretch of 3. Do you see when we go over 1, they went up 1, 2, 3. All of them kind of hit right there. Very important. And then the other ones go the opposite. So again, this has a stretch and a shift. And you can see all the functions, all related and very similar. Values shared.